In this video, I try to redeem myself from the previous failed attempts to lay out the PCB. I think I had 4 fails and published 1. I don't remember anymore. Anyway, let's get into it.
Hi, my name is Adam. I'm building a 16-bit computer from scratch. I hope you'll join me on this journey.
I started rewiring or rehooking up each of the traces on this PCB. I did reset the size of it to be 100 millimeters by 100 millimeters. And I think that's the largest that I want to go because that's where I get a price break from my vendor. I was working on the right-hand side of the PCB, and I ended up with, well, more than 3 hours worth of video. So I'm working on trying to cut this down to make it a reasonable length and show enough detail to get my point across, but not every single hookup, which is going to be ridiculously long. So forgive me for speeding this up a little bit. Forgive me for the fade ins and fade outs. I want to make sure that the content is relevant and interesting, but not a sleeping pill. Bear with me as I go through this. I'll try to share the key things that I have learned as I've been going through this process. The first order of business here was to move everything off the PCB layout, the actual cut form of the PCB, so that I could reset it to be 100 millimeters by 100 millimeters. Now I was challenged because by default KiCad wants the origin of the grid to be the page origin or the page corner, and I wanted to be able to set that to be the corner of my cut so that I could reference everything off the corner of the PCB, not the corner of the page. And so it took me a few minutes to figure that out. There is a setting in preferences, and then you just have to identify where the grid origin is on the paper, and then that then becomes where your grid is aligned. Next up is changing the size of the grid to be 1/10 of an inch or 2.54 millimeters, making sure that as I'm snapping everything onto the grid, the pins will align with that of a breadboard so that I can do some testing a little bit easier. Then I position the interconnects for address bus 1, move the labels outside the PCB dimensions, and then found that through a quick check, and then now I'm relocating them back to where they belong on the board. And then I move in the ICs along with the rest of the interconnects, trying to roughly position them on the PCB. Even with just rough positioning, I'm having a tough time making everything fit. Turns out I do have a lot of room that I can actually scavenge just by reorganizing things a little bit. Next, I made some room by collapsing down the space between the LEDs. I wanted to make sure I could get a trace between the LED and resistor because I knew I was going to need that room. But I didn't need room for a trace and a half or a trace and 3/4, which is what I had now. I did the same thing for the control signals. With that done, I went through and resized the text to be 3/4 width, if you will, 0.75, so that the text would be able to sit side by side and still be able to distinguish one thing from another and keep KiCad from complaining at me that the silkscreen was overlapping. With that done, I took the opportunity to run the design rules checker and clean up anything that it found at that point, mostly silkscreen overlaps. Next is some more tuning of IC placement, still trying to make things fit. Okay, let's see what we can make of this. A couple of things. And when we're drawing traces, there's a few, and vias really, there's a few things that will come to pass here. I think the first of it is, I know that up here, I've got traces that are really short, and they go basically from each of these points. And so setting those up should be pretty much trivial to do, I should say. The challenge is determining if I want to put these on top or on the bottom. I think I want to keep them on the top for now. I think I want to keep as many traces as possible on the top and then go to the bottom only when I need to. The other thing is if I zoom in here, each one of these is labeled with what its network is, or what its net is. The other thing I think I might want to consider, or at least look at here, is if I rotate the capacitor like this, I think I end up with a slightly shorter trace. I'm not totally sure of that, but it should make it easier for me to drag traces around some of these pads. Now, the other problem is all of these register bits here, these are sprinkled throughout the entire build. And so I actually have to put these through one way or the other, on top or on the bottom, each of these pins here. So if I wire these up, it gets me to 8. And then, so now I have to take this down to, whoops. All right, so let's undo that because its destination is down here. So I also have to go in between those two pads. And then this goes to that pad. Now I just get into the fussy bits of routing each one of the 570 odd traces that I need to get routed on this PCB. You will see here that I've learned the ability of drag and drop on the traces, where I can actually change the route that they take by clicking on the trace and dragging it to a new position on the PCB. But the key is that it has to be on the active layer in order for me to be able to do that. Several times as I go through this, I am actually clicking and trying to drag something that's not on the active layer. The hotkey for changing the active layer between the two copper layers is V, and so you won't see me actually click over to the right. I'm using the hotkey on the keyboard. Now I realize that I can place a via right in the middle of a pad. That has its benefits because I don't actually have to create a trace anywhere. But the downside is it actually takes up enough space that I cannot pass a trace in between the pads anymore. So there's a little bit of a trade-off there, a good and bad. Next up are the LEDs and extending the register contents down or up, as the case may be. Once everything for an IC is wired up, then it becomes a matter of adjusting the traces. I'm still dealing with some pretty heavy congestion trying to get everything routed. I think I found a way around this, and so I neglected to record the first trace, but I'm going to pick that up now and see if I can actually make this happen. Now, unfortunately, that's going to require me to put a lot of traces on the backside, which I wasn't a fan of doing, but we'll see what happens. I managed to miss a trace. Let's go get that. Now I'm creating a new problem for myself where the traces on the front and back run in parallel. This means that I have no ability to get anything new into that space, something I plan on coming back near the end and addressing as I deal with my final traces. I'll have to move things around a little bit to create room for vias, moving bottom traces to one side, top traces to another. Another thing to keep in mind here is that traces that run in parallel like this are not necessarily a good thing. They can create some sympathetic voltages or sympathetic amperage. I don't know what exactly the correct term is, from one trace to another. And so I think in these lower voltages related to CMOS, that may not be a huge problem. I'm hoping anyway. So I guess that's one thing we'll have to bookmark and see later. Regardless of how this turns out, this actually ends up being the best layout I've done so far, so I think I'm going to press forward with it. So I still need to complete the PCB and then of course order the PCB and all the components that belong on it. I still have all of my other to-dos that I've been chaining along here from video to video, and I will knock those off probably while I'm waiting for components to show. Thank you. We'll see you soon.